With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is a piece of metal weighs 46 gram in air and 30 gram in liquid of density 1.24 into 10 raised power 3 kg per meter cube kept at 27 degrees Celsius. When the temperature of the liquid is raised to 42 degrees Celsius, the metal piece weighs 30.5 grams. The density of the liquid at 42 degrees Celsius is 1.20 into 10 raised power 3 kg per meter cube. Calculate the coefficient of linear expansion of the metal. Okay, so we have been given a condition that the metal weighs 46 gram at 27 degree Celsius in air. Okay, 46 gram in air, and when this metal block is dipped into liquid of density, how much? Density of liquid 1.24 into 10 raised power 3 kg per meter cube. Correct. It weighs how much? That is 30 grams. Correct. Now first of all, let's convert the unit of density into gram per centimeter cube. Okay, so 1.24 into 10 raised power 3 into converting kg into gram is 10 raised power 3, and converting meter cube into centimeter cube is 10 raised power 2 whole cube. Correct. Centimeter cube. So this will come as, so density of liquid will come as how much? 1.24 gram per centimeter cube. Correct. Now when the temperature raises to 42 degrees Celsius, the block weighs how much? At 42 degrees Celsius, the block weighs 30.5 gram, and its density becomes how much? 1.20 into 10 raised power 3 kg per meter cube. Again changing the unit of density to gram per centimeter cube. The density of liquid at 42 degrees Celsius will come 1.20 gram per centimeter cube. Okay, now the condition given to us, let us suppose that this is our container and it is filled with some liquid and our metal block is dipped into it. Okay, so the metal block will weigh mg in the vertical downward direction, and the liquid will apply a buoyancy force on this block. Okay, so the principle of flotation will come into action, and we can calculate the apparent weight of the block as, so apparent weight of the block will be given as mg minus buoyancy force, and apparent weight will be what? Mass in the liquid into gravity, acceleration due to gravity, is equals to mg minus buoyancy force. From here, if we calculate the buoyancy force, will come as mass of the block minus mass of the block in the liquid into acceleration due to gravity. Let us suppose it equation number 1, and as we know that the buoyancy force is equals to how much? Weight of the liquid displaced. Correct. Now weight of the liquid displaced, and the weight of the liquid displaced is how much? The density of the liquid into g into the volume displaced. Correct. And the volume displaced is how much? The total volume of the block. So let us suppose the volume of the block is v, so it will be v. Okay, now substituting this value into this equation number 1. Okay, so what will come is buoyancy force is equals to density of liquid into acceleration due to gravity into the volume of the block, or the volume displaced by the block, is equals to mass of the block into mass of the block in liquid into acceleration due to gravity. From here, acceleration due to gravity will cut off, and the volume will come as mass into mass of the block in liquid divided by density of the liquid. Okay, so it we have calculated just a second. Yeah, so we have calculated the general formula to calculate the volume. Okay, so calculate the volume at different temperatures, that is at, first of all, calculate the volume at 27 degree Celsius. Okay, so initial volume will be what? Mass of the block in air minus mass of the block in liquid at 27 degrees Celsius divided by density of liquid at 27 degrees Celsius. Correct. So mass of block in air is given as 46 grams minus mass of the block in liquid at 27 degrees Celsius is given as 30 grams. Correct. Whole divided by density of the liquid at 27 degrees Celsius is 1.24 gram per centimeter cube. Correct. From here the volume will come as 12.903 centimeter cube. Okay. Now similarly calculate the volume at which temperature? 42 degrees Celsius. Correct. So it will be the mass of block in air minus mass of the block in liquid at 42 degrees Celsius divided by density of liquid at 42 degrees Celsius. Correct. From here it will come as 46 gram minus 30.5 grams whole divided by 1.20 gram per centimeter cube. Correct. From here what we get is 12.917 centimeter cube. Correct. So we have calculated the change in the volume. So applying the relation of the volume expansion, that is the thermal expansion, that is the final volume is equals to initial volume into 1 plus coefficient of volume expansion into the change in the temperature. Correct. And as we know that the relation between the coefficient of volume expansion and coefficient of linear expansion is given as gamma is equals to 3 times alpha, where alpha is the what? Alpha is coefficient of linear expansion. Okay. Now putting gamma in this above equation, what we get is final volume is equals to initial volume into 1 plus 3 times alpha delta T. Calculating alpha from this equation, what we get is final volume divided by initial volume minus 1 into 1 by 3 times delta T. Correct. Now substituting the respective values, we get final volume we have calculated as 12.917 divided by initial volume we have calculated as 12.903 minus 1 into 1 by 3. The change in the temperature is from 42 degree to 27 degree. Correct. Now when we calculate it, we get the coefficient of linear expansion as 2.3 into 10 raised power minus 5 per degree Celsius. Okay. So this is the required answer. Okay. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.